Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. It has been widely and incorrectly reported that machines now pass the Turing Test. They certainly do not, as of 2023. The Turing Test, or as Alan Turing himself actually named it, the imitation game, requires you to be the judge. Have a conversation with one person and one machine pretending to be a human, not pretending to book you a flight, someone you are probing, asking anything you want of. And with the emergence of systems like ChatGPT, it is well worth your time to practice your game. Perhaps artificial general intelligence is on the horizon. What will you ask a machine that claims to have this property? How will you test it? I don't know when that's going to happen, but I know we're getting closer. Maybe even close enough that it's time to start looking at the human brain for inspiration. In the past, I thought these were a top-down and a bottom-up approach that weren't likely to meet in the middle. The things I learned about machine learning and what limited things I learned as a non-neurologist about neurology led me to believe our fields really were quite a non-intersecting Venn diagram. People used to roll their eyes at the name neural networks as if they had anything to do with the brain. They were just tensor arithmetic. But with no machines passing the Turing test, the only example we have today of an intelligent system is the human brain. So perhaps it's high time to revisit this position. What can the human brain tell us about artificial general intelligence? That's the main theme for today's episode.
I'm Lin Zhao. I'm currently a research scientist in the United Image Intelligence. And I just graduated from the University of Georgia, and my Ph.D. dissertation is about the Brain-inspired AI.
I'm Zhang. Currently, I am a Ph.D. candidate at the University of Texas at Arlington in the Computer Science and Engineering Department, and my advisor is Dr. Dajiang Zhu. My research topic mainly focuses on two major problems. The first one is using machine learning and deep learning methods to integrate the multi-scale and multimodal brain imaging data to better understand brain fundamental organization principles and brain disorders, such as Alzheimer's disease and autism. And the second problem is applying the neuroscience knowledge to design more effective and efficient deep learning method, that is the brain-inspired AI.
Both of you are on the paper When Brain-inspired AI Meets AGI. Could you share some background on how the paper came to be?
Our group has worked on these topics for many, many years. We work on the brain image. We want to investigate about the brain structure and function. And we know that the brain has intelligence, right? So we would like to find the connections between the brain and the artificial intelligence. We want to use prior knowledge from the one domain, like the brain, the brain science. Maybe we can use this prior knowledge to get the design of the other domain, like the artificial intelligence. And in turn, we can use our knowledge in the artificial intelligence, like the neural network, to study our brain. So that's the reason why we have this paper. And now, recently, especially for the ChatGPT, this is become more popular, and the AGI looks like it's on the way to our real world. So this is just a survey paper so we summarize some, the background and also our contributions and other bodies' contributions together, and to give to the community a survey about the connection between the brain-inspired AI and also the AGI. Yeah.
We both have some research study about brain and artificial intelligence. As we know, brain is the most powerful and complex, most powerful AI system, as we know, right? If we can get some inspiration from brain to guide us to develop more efficient and effective AI system. And in our previous study, we found that some principles or rules in the biology system also can get some very good performance if we apply them into the AI system, especially at this exciting time point, such as the ChatGPT and the GPT-4. These very large models bring us to our new eve in the AI development. So at this time, we want to review the development history of the deep neural network or AI system, and to find if we can get some insight from the development of the two subjects, including the brain and the neural network.
Well, the idea of a neural network, it obviously takes its name in part inspired by the brain. But when I was trained about neural networks, it was done in a almost purely mathematical way and seemed disconnected from neurology. In fact, neurologists at my school would roll their eyes and say, "Oh, you're doing something different. You shouldn't call it that." How do you feel about neural networks? Are they the type of brain-inspired AI you're discussing, or was the neurologist I spoke to so many years ago correct?
Actually, I think there are many connections between the brain and the neural networks we have today. For example, there are some connections between the neurons, right? And also there are some connections between these nodes in the neural network. Actually, they are similar in some form, but mathematically it's different, right? We just want to mimic the neurons in our brain to build the neural network, but there are some differences. First, I think for the neural network we have, it's much more simple. Before the ChatGPT or GPT-3 and GPT-4, it's relatively simple. But the brain is very complex. In our brain, we have maybe 100 billion neurons in our brain. And also there are many connections between these neurons, right? So for the neural network is simple. But now when we reach a large scale, like the GPT-3 or GPT-4, we have many parameters within this neural network. They are in the same scale as our brain. I think the neural network, like the GPT-3, is more powerful, and they can understand the human's language and do many things. In this way, they are similar. And also, there are some other differences. Like for the neural network, we need to use a lot of data to train this neural network. Like we have maybe 1 billion images to train neural network. But for the human beings, it's different. For example, if I give you a picture like a dog, right, and then I show you this is dog, and then I give you another picture like that's a corgi, and you will easily distinguish that this is a dog. But for the neural network, it's different. So for the neural network has may not be able to learn from few samples. They need a lot of data. That's the second difference.
Modern data teams are using HEX to 10x their data impact. HEX combines a notebook-style UI with an interactive report builder. This allows data teams to both deep dive to find insights and then share their work in an easy-to-read format to the whole org. In HEX, you can use SQL, Python, R, and no-code visualization together to explore, transform, and model data. HEX also has AI built directly into the workflow to help you generate, edit, explain, and document your code. This is the missing piece of your data science stack. The best data teams in the world, such as the ones at Notion, AngelList, and Anthropic, use HEX for ad hoc investigations, creating machine learning models, and building operational dashboards for the rest of their company. HEX makes it easy for data analysts and data scientists to collaborate together and produce work that has an impact. If you're looking for a job, you need to have HEX on your resume. If you're a data science decision maker or just a thought leader in your company, you would be derelict of duty to not check out HEX.tech. Make your data team unstoppable with HEX. Sign up today at hex.tech/dataskeptic to get a 30-day free trial for your team.
Maybe our brain has a biology foundation, but for neural network, it is based on some mathematic foundation. Anyway, we need to train some large neural network from scratch and then use it in other or downstream tasks. But at the beginning, we need to initial them by training from scratch. However, our brain, we don't need to train our brain from scratch. Why? Because we have, heredity. We already have our very complicated brain. They have the basic foundation, and using that brain, we can recognize, we can know the surroundings. But for neural network, we don't have that foundation. The differences between the brain and neural network is the detailed rules. However, we want to use the general rules from brain to guide the neural network. We believe the two system can share some general rules, but the detailed implementation can be different, just like that. Because I remember our paper published in Nature before, they discussed and explored the mammal brains, a lot of mammal brains, and compare their intelligent capability and find two factors influence the intellectual capability. The first one is the number of neurons, just like the number of nodes in the neural network, the scale of the neural network. And the second one is the connection rules, how the network connect and transmit the information. That is the different kind of neural network. In neural network, we also find if one network, they reach our scale, their ability will be extremely improvement. So that is the consistent with the brain. The second one is a lot of researchers try to develop new architecture, powerful architecture, because we want to explore the new and powerful information transmission. This is also consistent with the brain. If the brain have more neurons and these neurons connection with each other in a more efficient way, the brain will be more powerful, more intelligent. I think these general rules are shared by the two systems.
We mentioned that the brain has about 100 billion neurons. Mm-hmm. You can't buy a computer with 100 billion bytes of memory yet. Yeah. But by the time you can, should we assume it will have AGI?
I think this is a problem currently AGI faces. Why? Because in our another paper, we compare the scalability and the cost of the AGI system. Although the currently large language model such as ChatGPT and GPT-4 have very powerful performance, but their cost is also very large. If we create more large neural system, we will pay much for them, and sometimes we can't afford it. But for brain, although we have thousands of hundreds neurons, but they are not so expensive. So I think we need to find a more effective way to make current neural network more powerful, not only to add the scalability. I mean, to make them bigger and bigger is not the best way.
Actually, I think there's less connection with the size of the memory. If you refer to the memory of the neural network, I would say yes, but it's not the memory of the computer. We can have many, many memories in our computer. We can store many, many data, but it's not the way the AGI looks like, because we need to find the connections of all the correlations between this data. And then we will, for example, let's use a language as an example. We have some characters, right? Like A, B, C, and we also have some words like you and me. And also we will have some sentences, we will have the paragraph, and finally we will have an essay or a paper. So that's the ways our knowledge are organized. If we just have so many memories, we just store the data there. Okay, there is nothing with intelligence. But if we can use some, algorithms or the neural network to find the connections or summarize some, probabilities among this data or the data distribution, that's the way we reach to the general intelligence. And for the ChatGPT or GPT-3 or GPT-4, they have some kind of the intelligence. They can understand what you are saying, and they will give you the desired response. That's because some of the neurons will memorize something. Like, for example, I read some paper in how the memory works in the neural network, especially for the GPT model. They found that in the MLP, that's multi-perception layers in the neural network, in the GPT model, these neurons actually memorize something, and these will self-attention mechanism to organize these memories, and they will produce intelligence. I think that's a way seems like our human brain have, right? So in our human brain, we'll have some neurons memorize something, and we will have some neurons activate to connect these memories, and then we will have intelligence. In this way, they are the same. Yeah. So if we have a large neural network, maybe more than 1,000 billion parameters in neural network will memorize something. In this sense, I think if we have large memory, we will have more intelligence.
And how to use the memory to conduct reasoning is another important thing. It doesn't mean you have more knowledge, you have the better reasoning ability. It's not true, right?
Good point.
So I think AGI also want to have our high reasoning ability. It means the knowledge you remembered or stored have the power. If you cannot take advantage of the large knowledge the system stored or memoried, it cannot do anything.
So we've touched on a few of the ways that AI can be inspired from the human brain, like you were mentioning reasoning and earlier scale. Could we go through the just broad categories you're looking at?
Yeah, I think brain and the artificial neural network is not the single direction. I mean, it's not just the brain-inspired AI. Actually, the AI system also can help us to understand our brain. As long as we have deeper and deeper understanding of our brain, maybe we can learn more useful rules, and these useful rules can guide us to develop more effective and efficient AI system. Because brain is as I mentioned before, is the most powerful intelligent system we know. So I think it can provide us good inspiration as the two domains, the brain and the neural network, develop in our new stage. I think maybe we will have our different or better understanding of what intelligence is. Maybe intelligence is not only one style, just like the human brain. We can have other styles of intelligence, but at I think current stage, the brain is the most powerful one. In the future, maybe we can develop more powerful AI system. But currently, what I think the better way for that is to get inspiration from brain and use the current advanced AI method to help us better understand brain. I think it's a good improvement for both domains. Yeah.
Well, I was trying to think of the strongest criticisms I have against the work. Like, why would you not want to explore brain inspiration? I came up with two I wanted to just get your thoughts on. The first is that I could claim most of the major advancements in AI, something like the transformer architecture, they come from computer science. There's no analog in the brain. Why should we think that we need help?
Actually, for the transform model, actually they have some connections with brain actually. So the transform model has two basic parts. The first one is the self-attention module. The next one is MLP, that's multi-layer perception, right? So actually for the self-attention is some like the attention mechanism. It's a way, it's just used to find the connections between the different words, right, for the transform model. Actually, this is a way how our brain works, like just as I mentioned. Like when I ask you questions, we will explore the connections between the question, maybe several words in the question, and also the connection between your understanding of these words and your prior knowledge or your memory. You need to explore these connections, right? So that's the first thing. And also for the MLP, as I just say, it's more about memory. It will memorize something. At the beginning of the transformers, the inventors do not think about too much about from the brain, the knowledge from the brain. But there are some connections between them. Yeah. Before the transformers, the most popular model I think is a convolutional neural network, right? They have hierarchical organization. We have different layers with different receptive fields, and actually that's how the human visual system works. Right? They get the inspirations from the human brain, and also for the neurons, like the basic neural network or the MLP. They try to mimic the neural network in the human brain. So there are a lot of connections. And also, when we use a transformer, we stack transformers decoded together, we build the GPT model. And when we increase the skills of the GPT, to maybe more than 100 million parameters in the GPT model, we have some kind of the intelligence. In this way, they are similar, actually. Actually, for the transformer model, if you train a transformer model, there are so many connections between these neurons. And if you give you a new input or try to, let the transformer to learn some new knowledge, they will change the weight of the parameter. And in that way, the neural network will forget something. Actually, it's not efficient. If we want to memorize the most important things in the transformer model, okay, we currently we have, even though we have some approach to optimize transformer model, but it's not as efficient as a human brain. So maybe we can use some rules from our brain to optimize the transformer model to make it become more sparse and more efficient and still have the same power.
Yeah, I think the general rule between the transformer and our brain are similar. Why? Because compared to the previous language model, transformer, the one advantage of transformer is it can have the overview of all the input. I mean, it can get the long distance dependence, because from the first input and the last input, the model can get all the information. However, in our brain, it is the same, because in our brain, our short-term memory and the long-term memory are stored in different places. The sleeping can help us to change the short-term knowledge into long-term. So maybe sometimes when we say something, we can refresh our long-term memory. If one brain can effectively record their long-term memory, the brain is more power. So in AI system, if a model can get more information and long dependence information, maybe the system can get better performance. I think from this perspective, brain and the AI system, just like the transformer, they share the same character. But the difference is how they implement this. Yeah, I think both the transformer and the brain, they actually learn the relationship between knowledge. They want to build the connection between separate knowledge. Then, if we get a task, we can, based on the connection, can record the memory knowledge. However, in transformer, we use the attention mechanism. In our brain, actually, we don't know the exact mechanism, but they have some mechanism. The two systems can use different mechanism, but their goal are the same: to build some rules to help the system quickly record the useful knowledge, to build the relationship between knowledge. Yeah.
So I want to present you my second challenge then. I feel like you've defeated the first. One could say that the brain is the product of evolution, and it took evolution millions and millions of years to come up with this design, and it's not even, the most efficient design in many ways. Maybe taking brain inspiration is the slow path, and we could get on the fast track. What do you think?
I don't think brain is the slow track or the artificial intelligence is the quick track. Currently, there are a lot of neural network, different types in transformer R and something like that. And maybe every day there are a lot of papers to propose a lot of different architecture. It doesn't mean every different architecture have a big breakthrough in their performance. So we just try to explore different architecture. A lot of different architecture just means we are interested in this field and we want to explore more potential in different architectures. It doesn't mean every architecture have a big breakthrough. It is the same in our brain. And we researchers in neuroscience have explored different perspectives of brain, like the structure-function relationship and the brain disorder, something like that. But we also have very limited understanding of our brain. So from my perspective, I think both the domains are not, the development of both brains are not so quick. Yeah, we have a long way to go.
Yeah, actually, Yeah, in my opinion, I think what is the ultimate goal of the artificial intelligence? That's intelligence. And where we have the intelligence in our brain. So actually, the brain is our ultimate goal for the artificial intelligence, right? So currently, the brain is still the most complex and the efficient system in our world. That's the intelligent system in our world, okay? So we still need, if we can design a neural network or some systems that can reach the ability of our brain, that's okay. We will say we will reach the artificial intelligence, but now we don't, right? So we still need to learn from the brain. And actually, even after maybe several billion years of evolution, we have the brain right now. Yeah, but it's our ultimate goal, right? The advantage of the neural network is that we can quickly evolve the architecture of our neural network. Use the brain-inspired AI not means we need to copy everything from our brain. We just need some, principal guidelines to reach our ultimate goal. That's artificial intelligence. Our system should have some intelligence. So that's the ultimate goal. So I think we still need to learn from the brain at this time point.
Yeah, actually, I think actually the brain designed the AI system, right? Because people design the AI system and people use their brain to design AI system. I think so. Only one day, if the AI system have our great emergency capabilities and they can create the ability that a human cannot do themselves, at that day, I think AI system can pass the brain. Before that, I think brain is still the most powerful one.
Well, there's one important topic that's covered in the paper that we haven't gotten to yet, and that's alignment. I know that if I were to, let's say, hire a new employee, I might need to train them on something. Like, let's say they're going to send emails to customers. I need to tell them about, what to send and stuff like that. But I know once I get them going, they're not going to send an email that tells the customer to quit and find a competitor. I'm not so sure that an AI chatbot, the current ones, wouldn't just go off and do something kind of crazy like that. So we definitely have alignment to think about. How can the brain inspire future research in that area?
Right now, I think for the alignment, for example, the OpenAI use reinforcement learning from feedback to align their models with human feedback. Like they have a teacher, they will teach the model how they should behave, right? So it's just like the human teach their children. So that's the alignment. And also, I think if we can design some powerful AI system in the future, maybe we do not need the alignment because we can just maybe use some ways to customize the behavior of the neural network. At that time, maybe we will not need the alignment. Yeah.
Well, we've touched on a bunch of different ways in which brain-inspired work can come into the field of AGI. Could you both of you maybe share some of your thoughts about the future? What are some of the most inspiring or areas that have the most potential to drive things forward?
In the future, I think the most important thing is the multimodality, how to know the world. Because from a human view, we know each objective from using multiple modalities, just like the text, voice, video, all these things. But currently, the AI system cannot perfectly merge all the modality to identify one sub-object. Although we try to develop the multi-modality neural network to conduct that, but we're still at the infant stage, I think.
Actually, for the AGI, I think we are on the right way. And currently, I think for the human intelligence, I think the language is a human intelligence. Now, the large language model, like the GPT model, is much more powerful. It can think like human beings, right? It can produce some, the reasonable answers for your question, and it can do many, many things right now. I think the language is an intelligence. It's for the language model, it's just like the CPU in the computer. And in the future, we will have many other parts. Like for the human brain, we will have some visual system. We'll process some visual information, and we also have some audio system that will produce the sound, the information from the sound. and then they are all produced by the brain. And now the language is powerful enough. The language model is powerful enough, but we do not have the intelligence about maybe the visual. I think for example, for the visual field, like the computer vision field, the next step is we need to convert the information or convert some the values in the pixel in an image together. Like we need to process an image. We need to get some semantics from the image. Once we get the semantics, we can use the language model to process these semantics and produce the so-called intelligence. And this is also true for the audio and for the other types of inputs. If we can align, so we just need a convention from the image or the voice to the semantics. If we finish this step, we can use the language model to produce artificial intelligence. Yeah, I think maybe that will become true in the next few years.
Did I understand that correctly, that you think perhaps in the next few years even we could achieve artificial general intelligence, or were you speaking about something different?
Yeah. Maybe in the next few years. Now, I think the language model is just like the CPU in the computer is powerful enough. Now we need some other inputs for this language model. For example, we have a camera for our computer, so the computer can receive the visual information, right? We have a microphone. The computer can receive your voice. And then the computer, in the internal of the computer, they connect these things into just like a signal, and the CPU will process this signal to perform some task. Now it's just like the artificial intelligence system. We have a CPU that's a large language model. And now we need to convert the visual information to the semantics. Right? Semantics that's a basic component, I think, in the artificial intelligence. That's the semantics. Also in the human intelligence, that's the semantics. If we can find the connections between these semantics, that's we call the intelligence. Right? Yeah, so we need to convert the image, use some models to convert the input image into the semantics. For example, we have input image with a dog, and then the output of this convention will be a dog, the semantics of the dog. And then the language model can understand that the image has a dog, and then they can produce some response maybe for your input, like the image and also the language.
Yeah, I understand. I think it's the same way the multimodality. We need to use the comprehensive information to describe one object, including the language, maybe sound, video, image, something like that. We need our better architecture to merge all these multimodality informations together, not just to separately focus on each modality.
And Lu, are you equally optimistic that we might encounter an artificial general intelligence in the near future?
I'm not so positive. I'm negative about that question. I don't think we can achieve the AGI, artificial general intelligence, in a few years. Maybe 50 years. 50.
50, okay, yeah.
Yeah, half a century, I think. At that time, maybe we can achieve artificial general intelligence, because I think we have a long way to go.
And the distance we have to go, do you think it's theoretical barriers or hardware barriers, or what's left to do?
Theoretical. I think theoretical. Actually, the human ourselves, we don't have our clear, recognition of intelligence. What is intelligence? Based on that, we don't know what our artificial general intelligence can achieve. So during the development path, we also need to think about that. So I think we need a long way to go. Maybe in a few past years, we can achieve a better stage. But at that time, we will still have some confusion about the intelligence, the concept. At that time, we will rethink about that. Yeah, I think we need to repeat that several times. And at some point, we have a clear definition about intelligence. At that time, maybe it is the time we can achieve the artificial general intelligence. I think not now and not in just several years.
Well, I hope I get to see and interact with it whenever we do achieve it. It's exciting times.
Yeah. I hope before I die, we can achieve that, because I really want to see how powerful the AGI. Yeah.
I feel the same way. So hopefully my longevity is within the boundary of the human advancement.
Yeah.
Well, is there anywhere listeners can follow you both online, learn more about you and your work?
Yeah, I think we will post all our current papers and publications on our homepage.
Excellent. We'll have links in the show notes for listeners who want to follow up. Thank you both so much for taking the time to come on and share your work.
Oh, thank you. Thank you so much.
Yeah, thank you so much for this interview.
Well, that concludes this installment of Data Skeptic Machine Intelligence. Hey, I'm running a contest. Just for fun, we're giving away a free virtual pass to the Data Connect conference. In order to win, you've got to participate in our contest, guess the number of tacks in a jar. We're going to repeat that old Galton experiment and see if the mean average of all the guesses is truly closer than the best guess. Go find the image on our Twitter, that's twitter.com/dataskeptic, and email your guess to contest@dataskeptic.com.